Hey AAF students, welcome back to your next lesson. So in this video, we are going to be not using a calculator, right? Oh, without a calculator. We haven't used calculators at all at this point, so please don't pick them up. So without the help of a calculator, use algebra and my understanding of matrices to successfully evaluate, analyze, and apply determinants of, ooh, how exciting, 3x3 matrices, right? So you guys last weekend and in our last live session talked extensively about 2x2 matrices, right? And how you find the determinant of 2x2 matrices and how you use them to figure out the adjoint and what else was I going for? The adjoint and how you find the inverse, and then whether you're left multiplying or right multiplying in order to solve, right? So like if you have AX equals B and you're solving for that, you're going A inverse times A times X equals A inverse times B, right? Because this is just the identity matrix times X, which is just X. So X would be A inverse times B, right? So you talked about that versus it being XA equals B. And here you'd have to go A inverse, which would be B A inverse. And then that would give you the identity matrix, X times the identity matrix, which equals B A inverse, right? And that multiplication is not commutative, right? So like the order that you're multiplying in matters. So you talked pretty much like at length about that and even how you use this for systems, 2x2 systems. Right, and how you can do it with a coefficient matrix, a variable matrix, and an answer matrix. And this is another way to solve a 2x2 system. So I want to start off and really emphasize that we're not going to do, we absolutely could, but we're not going to go quite as far with a 3x3 matrix. And I also want to emphasize that this would be possible with 4x4 and 5x5 and 6x6, right? So I can do this with any square matrix, right? That's what this stuff would work for. So we are going to find the multiplicative inverse of 3x3s and 4x4s and 5x5s and etc. But that is stuff that's going to happen on a calculator, not because you are not fully capable of doing that, but it is tedious. And I think we really want to emphasize that you know how to do it, and that at some point, like, that doesn't need to happen by hand, right? Like you can demonstrate your understanding of that through 2x2 and then showing us the setup. So this is really finding determinants of 3x3 matrices by hand without a calculator is really the last non-calculator objective of this topic. Okay, so it's more so that we're going to evaluate and analyze, like, is it singular? Does it even have an inverse? Rather than actually applying this yet. Okay, so let's get ourselves started. As we get started, let's do a quick review with 2x2. Oh, that rhymed. So evaluate, right? And so this was the really important piece of notation. Please, please know your notation, right? If this just says evaluate, what does that mean? This should be a scalar value. These bars indicate determinant, right? That means find the determinant. That is something that we expect you to know at this point, right? So when I'm finding the determinant, I'm multiplying 7 times -2, and I'm in the habit of showing work, -5 times 8. And that's going to give me -14 plus 40, which gives me, that's 40 minus 14, 36, right? So this is not singular. If I went a step further, and let's say I gave you this, and this was A, and I said, find A inverse. You would do 1 over the determinant times the adjoint, right? So times, I switch these two, and I negate these two. And then I can distribute that in. That's scalar multiplication now. And I get, what is that? -1 over 18, 5 over 36, negative, oh no, I can divide them both by 4, right? -2 over 9, and then 7 over 36, right? So this would be the inverse. If I did A times A inverse, I should get the identity matrix, right? Because this is its multiplicative inverse. What would its additive inverse be? I would have to add -7, 5, -8, and 2, because if I did that, I would get the 0 matrix. Yay, okay, it's a good review there. Next, this is asking us to find the missing variable, and so again, we need to know that the notation means that we are finding the determinant. So I would go ahead and do 3 times 2 minus 7x equals 83. So 6 minus 7x equals 83, and now you've just got a two-step equation. So minus 6, I get -7x equals -77, and therefore x equals 11. And we are fully capable of plugging that back in and seeing, does it make sense, right? 6 minus 77, ooh, this is positive. That should be a -11. 6 minus -77, two negatives are positive 83. See, good idea. I'm glad I checked my work. Amazing. Okay, so now we're going to really take a look at finding the determinant of a 3x3 matrix. And in the last video lesson, not in class, I shared an applet on GeoGebra that it was a little, it was an extension, and some of it you're not really responsible for, but for those of you that are really trying to understand, like, what is this idea of determinant, when you're dealing with a 2x2 matrix, it's the area, right? So like, we're really looking at these like vectors, and when it's 2x2, it's in 2 space. When it's 3x3, we're looking at it in 3 space, right? So like, you're finding this volume, and so I do have like a little applet to try to show it, but it's a lot harder because we haven't really, yeah, like I can visually show it, but you'll see. I'll show it a little bit later into this video. So there's 2 different methods that I'm going to go through, and really there's one method to find the determinant, and the other one's kind of like a shortcut. I have a personal preference. I'm going to attempt to not tell you which one is my personal preference, and just really encourage you guys to try both of them and see which one works best for you, and consistently works best for you, right? But again, this is something that just takes some practice. So method 1, we're finding the determinant of this. So think like I'm finding volume, like here's a point, here's a point, here's a point in 3 space, like X, Y, Z. And I'm trying to find the volume of it. So I'm going to take the spot 1, 1, and I'm kind of just going to ignore these parts. And right here, I'm going to be finding the determinant of this. Okay, so like this, and then I'm finding the determinant of this little 2x2 matrix almost. So I've got 2 times -2 times 2 minus 5 times 4. I should have put parentheses. Sorry, guys. Awesome. So then I'm going to keep going, and now I'm going to focus in on 0. I'm going to be taking 0, ignore, ignore, and I'm going to be looking at these and almost treating them as if they're a 2x2 matrix. Whoa, sorry. Whoa, sorry. Whoa, sorry. I don't know what just happened. My bad. Right, so I've got 1, -1, 5, 2, and I'm finding the determinant of them. So 2 times 1, -5 times, I'm sorry, 5 times -1. Okay, and then I'm going to do it with the last one on that first row as well. 3, and then over here, focusing on that little matrix, and I'm doing plus 3 times 1 times 4 minus -2 times, oop, that should be a -1. Sorry, guys. Thought I fixed that mistake. So really the key things that you want to recognize right here is, look at this. Here, I'm subtracting. Here, I'm adding. So you're doing the opposite. Right? So that's really the key things that I want to focus on that I'm doing here. Okay, so when I go ahead and I simplify this, I get negative 48. Man, I thought I fixed this. Negative 48 minus 0. This is not what I get. It's fixed on your PowerPoint if you printed it. Sorry, guys. Negative 48 minus 0. And this is not minus 0. What should this be? 3 and then 4 minus, this is 2. So 3 times 2, which is 6. So negative 48 plus 6, so my determinant is negative 42. So the volume would be 42. The negative kind of just tells you the direction. Okay. So sorry. It's negative 42. Okay. So that's method 1. Right? And just to summarize what happened here, so I have, this is my general 3x3 matrix. Remember A, B, C, D, E, F, G, H, I. The determinant of the matrix can be found by this formula. So A times the determinant of this right here. B times the determinant of that little matrix. Plus C times the determinant of its little matrix. Right? So just minus and then plus. Okay? So a shortcut to this is what we're going to do with method 2. I mean, I don't know that shortcut is the best word, but another process for getting the same answer is what we're going to do with method number 2. So in method number 2, I'm going to take my first 2 columns and I'm going to rewrite them to the right. Okay, so I rewrote my first 2 columns. You need to be neat and organized about this. And I'm going to take these 3 diagonals. Those are my only 3 diagonals, right? Like this is not a full diagonal. There's only 2 terms. Okay, so I'm taking my first 3 diagonals and I'm going to multiply across the diagonal and add those up. Okay, so 2 times negative 2 times 2 plus 0 times 5 times negative 1 plus 3 times 1 times 4. And I'm showing my work. And then from that, I'm going to subtract the sum of the product of the other diagonal. So 3 times negative 2 times negative 1 plus 2 times 5 times 4 times plus 0 times 1 times 2. When I get that, I've got negative 8 plus 0 plus 12 minus 6 plus 40 plus 0, which is, no, it's not. Sorry. This shouldn't be there. 4 minus 46, which is negative 42. I apologize, guys. I actually fixed the PowerPoint. I went to go redo this, and apparently I'm not using the fixed PowerPoint. My fault. Right, so this is going to get me the same method. So just to clarify what's happening here, so here's what I have. I've got, this is A, B, C, D, E, F, G, H, I. So just so you can see why this process will also work. So this is A, this is D, this is G. This is B. This is E, this is H. Right, so when I'm doing this, I'm doing A, E, I plus B, F, G plus C, D, H. And then minus, from that I'm subtracting G, E, C plus H, F, A in no particular order plus I, D, B. Right, so that's what I'm doing here. When I use that other method with the little determinants, I'm doing, and maybe you can picture this, I'll grab a new color so maybe it'll be a little bit easier. I'm doing A times EI minus FH. And then I'm subtracting B, so now I'm over here, and here's my little determinant, DI minus FG. DI minus FG. And then plus C, that last spot, with this determinant, DH minus EG. Right? So if I were to multiply this out, so let's say I'm going to distribute, I get A times EI, AEI, minus, so it's going to be over on this side, A times F times H. A times F times H. And then minus B times D times I. Minus B times D times I. And then double negative plus B times F times G right there. Plus C times D times H. There you go. Minus C times E times G right there. Right? So it's just a different way of representing it. And so when you're moving it over, those are the things that you're going to be multiplying together. And so it's just another algorithm that gets you the same results. What I really want to encourage you to do is not necessarily memorize a formula, but try to like remember what you're doing. So some of that comes with practice, right? You gotta practice. So here, let's see. Here's how it works, right? So you're sliding it over. You need to be like pretty organized about it when you're doing it. Don't just picture it in your head. You got to actually write it out, get in the habit of showing work. And that's how you're finding the determinant with it. So let's see. I was going to show this. So was this the example that we just did? It's very nice. My computer's going to freeze. Oh, there you go. Okay, so let's see. It was 2, 0, 3, 1, negative 2, 5. Is that what we just did? 2's, yes, it is, right? So you can kind of see, like, I attempted to do it in 3 space just so that you can kind of see what's happening, but I plotted each point. And so what we're finding is the volume of this 3D shape. Hopefully I plugged it all in correctly, but just to kind of give you that visual. This isn't as simple as me being like, let's find the area, because there's a little bit more involved that we need to figure out. And so I'm not going to get into that right now, but just you're more than welcome to go and do some more research, play around with it. But it is pretty neat. Okay, and that's what we're doing when we're finding these determinants in 3 space for this one. Okay, so let's do another example. Here you go. So this would be a really good time to maybe pause the video and try this. So evaluate. Here's the notation that we're looking for. So notation means find the determinant. It means that I should have a scalar as an answer. So I'm going to use method 1 for this. So 2 times 0 minus 2 minus negative 1 times negative 8 minus 1. You need to be neat with it. Plus 3 times negative 4 minus 0. Okay, let's simplify. So this is going to give me negative 4. This is going to give me, what is this? Negative 9. So that will give me 9. So minus 9. I'm going to do both methods, actually. And then plus negative 12. So negative 4 minus 9 is negative 13, plus negative 12 gives me negative 25 as my determinant. This is not singular. This would have an inverse. If I wanted to do method 2, I would go ahead and negative 2, 1, negative 1, 0, 2, and then multiply along the diagonals. You gotta be pretty neat with it. So I've got, that's just gonna be 0, plus negative 1 times 1 times 1 is just gonna be negative 1. 3 times 2 is that a negative 2? Yeah. Negative 6, negative 12, and then minus, and look at this other diagonal. That's gonna be 0 plus 2 times 1 times 2 is plus 4. 4 times negative 2 times negative 1 gives me, is that 8? I think it's 8. So that gives me negative 13 minus, no, I'm certainly wrong somewhere, guys. 2, negative 2, 1. That's a positive 8. It's a 4, that's a 0. This is a 0. This is a negative 1. And that's a negative 12. So that's negative 13 minus, oh, I'm adding. Sorry, I'm not wrong, guys. I was doing 32 in my head. Negative 25. So I get the same thing, right? So this would have an inverse. If you're interested in knowing more about how to find the inverse by hand, if you want to look up how exactly to do that, because it is still 1 over the determinant, and then you have to like reload the matrix. And so what you have to do here is you're going to be doing the transpose of the cofactors. And so what that means is that if I'm focused in this first spot, I'm going to be finding the determinant of this, and that goes in my first spot. Okay, and then in my second spot, I'm going to be finding the determinant of these, and that goes in my second spot. My third spot, right? And I would keep going with that and ignore more, and you're finding all of these values, and then you're doing the transpose of the cofactors. I encourage you to go for it and like look that up. I can point you in the right direction as well. It's not something you guys are going to be responsible for doing now, or that you will need to be able to do by hands, but I know that many of you guys are interested in knowing why things work the way they work and what is the algorithm that's happening behind the system, or behind the process. So go for it. Cofactors, if you want to look that up. So we're gonna finish up with these last two. These are actually on the supplemental practice worksheet. And so I thought maybe if we did 2 of them together, I encourage you to try to, you would take advantage of some of this extra practice, because I do think this is really important to just practice. So maybe pause the video, try this, and then come back and let's go over that. So I'm gonna rewrite this one. Sometimes I like to do it both ways. And 3, negative 9, so I get 9. Negative 2 and negative 2 is 4. 12. And then 3 and negative 2 is minus 6. Oh, I forgot I have an eraser now. How fun. Minus, I also have a highlighter. I should be using that. So I'm doing this one, and this one. That wasn't even very good. It's okay. Negative 3. 4 and 3 is 12. Negative 9, 18, so plus 18. Right, so 9 and could probably actually cancel some things out, but that's okay. 9 and 12 is 21, minus 6 is what, 15? Minus, this is negative 3 and 12 is 9. 9 plus 18 is 27. And then 15 minus 27 is what? That's the same thing about 27 minus 15, and that gives you 12, so this would be negative 12. Right, if you did it the other way, you're going to be doing 3 times 3 minus 4 minus negative 2 times negative 9 plus 6, and then plus 1 times negative 6 minus plus 3, right? So that would give you, this is negative 1, so you'd have negative 3 minus, this is negative 3, so minus 6, because that's a positive 6, and then plus negative 3. Negative 3 minus 6 gives you negative 9, plus negative 3 gives you negative 12. So I got the same thing both ways. Yahoo! Okay, and then in this last one, I'm going to do negative 3, 3 minus 0, that's nice with that little 1, and then minus 2, 0 minus negative 3 or plus 3, and then plus negative 3, 0 plus 3. That's minus negative 3. So this gives me negative 9 minus 6 plus negative 9. Negative 9 minus 6 gives you negative 15. minus 9 gives you negative 24. Right, so that's method, so this is method 2, this is method 1, and then this is method 1, and I'll do method 2 now as well. So if I do method 2, I'll go ahead and rewrite those first two columns neatly. 2, negative 1, 0, grab my highlighter, and I'll multiply on these main diagonal. So what does that do? Negative 9 plus negative 6 plus 0 minus, and then multiply on the other diagonal. What fun is this? Which would give you 3, negative 9, positive 9 plus 0 plus 0. Right, so negative 9 plus negative 6 gives you negative 15 minus 9, which again gives you negative 24. Yay! Woohoo! Awesome. Okay, guys, so you guys have access to this supplemental worksheet. You also are working on that Go formative, right? So that's something you should be working on. We would expect that, I mean, you could do part 1 and part 2 at this point. We would expect that part 1 is done by the next class and then part 2 by the following. So please make sure you are doing those. There's also a link to this other GeoGebra applet, which is pretty neat. And so this just there's also Delta Math. There's a lot of extra resources for you guys, but this generates different problems and then shows you the solutions step by step, which is kind of fun to play around with. So if you're looking for even more practice, go ahead and click on this. This is a great resource as well. So in this lesson, without the help of a calculator, right? No calculators have been used in this learning. I'll be able to use algebra and my understanding of matrices to successfully evaluate and analyze a little bit, not really apply, right? So this will happen later. 3x3 matrices. Again, if you want to look up how you find the adjoint of a 3x3, I encourage you to do that. I'm happy to, we're both happy to engage in any conversations about that and support you with that. It's not something that you are going to be required to do for us, but more power to you if you want to look into that. All right, everyone. So thanks for watching and we will see you next time.